Going to discuss about the topic cryptographic hash function. So let us see what is a hash function. So whenever you take the data of arbitrary length, the message, so it is whenever you apply a hash function, so you are going to get a fixed length of hash code, so which can be represented as h is equal to h of m. Now hash function. A hash function is the maps of a variable length message into a fixed length of hash value or a message digest. So you are giving the message document to a hash function to form the message digest or a fingerprint. So properties is nothing but first property, it should be of fixed length. So whenever you give hello world, you are going to give to the hash, then we are going to get a hash code of fixed length L. So this is clear text that it is easily read without using the key. The sentence is longer than the text above. So whenever you are applying this large number of text also, we are going to get the fixed length of digest. Even if you give less number of words or more number of words, the length of the digest is fixed. So arbitrary length of the message, fixed length digest you are going to get. Then chewing function or the digest function. So hash functions acts as a chewing or a digest function, where you are going to give the large amount of message, but we convert into the fixed number of length only. Even if it is a large amount of data, we are going to put them into the one fixed number of bits. Then hashing versus encryption. So whenever you give a hello world, a sample sentence to show the encryption. So we are going to encrypt with the key encryption, and we are going to get the as a ciphertext, and whenever this ciphertext is given with the key is decrypted, then we are going to get the original message. So in this we are going to give the key and encrypted, we are going to get the ciphertext. When ciphertext which is decrypted with the key, we are going to get our original message. But it is a two-way function, but in the hash function it is only one-way function. So when we are giving any message and the hash algorithm, when you are applying, we are getting the hash code, and this hash code cannot be written back to the hash to the original message. So it is only one-way function, there is no dehashing. Then where the hash functions is applied, it is used for the data integrity, message authentication code, digital signature, password storage, and intruder detection and virus detection. So non-key digest for integrity, modification detection, MDC. So keyed digest for the authentication, so non-keyed digest for integrity, key digestion for the authentication. So there you are going to use the method called as modification detection code. Here we are going to use MAC and HMAC. MAC is for secret key and press message. HMAC is MAC plus MDC. And also digital signature for non-repudiation. So we are going to achieve the integrity, authentication as well as the non-repudiation. So coming to the integrity, the recipient be confident that the message has not been accidentally modified. So when you are giving the message to a hash function, we are going to get a digest, and this digest is not changed by anyone. So we are going to check whether the message is same or not with the previous digest. If it is same, then we are going to put, or we are going to say discarded. So how we are going to achieve the confidentiality and integrity? Whenever you are taking the message, we are applying the hash function, then we are going to get a hash code. We append with the plain text message, then message with the function, we are going to compare and check whether the same hash code is there or not. If hash code is there, then we say it is having the same function, it has achieved the confidentiality and integrity. So how we have find out the confidentiality? For achieving, here we only have the integrity, because we are appending those values, but we are not encrypting over here. So encryption, to obtain the confidentiality, we need to encrypt the data. So in the second diagram, we can see we have achieved the encrypted with the encryption algorithm with the key. So here we achieve the confidentiality also. So taking the message, applying the hash function, we are going to get a hash code. Then we are going to take the message, plain text message, and then we are going to encrypt the message, and at the decryption end we are going to decrypt. So when you are encrypting, that means we are achieving the confidentiality. So in this case we have the confidentiality and integrity. So getting the authentication. So whenever the message is sent, we apply the MAC algorithm, and we applying with the key. We are going to get a MAC code. So taking the message as well as the MAC code, at the receiving end we are going to give the message and apply the MAC algorithm to check whether the MAC is same or not. If both are same, then we say as a authenticity and integrity as bot, or else not, we have not have the same values. So it protects the message integrity as well as authenticity by allowing the verifier, who also possesses the secret key, to detect any changes in the message content. So you can see here. So we have taken the message, then we append with the S values, then we going to get a hash, apply the hash function, then append the values with the message. So we get the message as well as the hash code, and compare with the message applying the S and the hash function. So when you are comparing, when you are getting the same thing, then we say both have achieved the integrity. So integrity and authentication. To achieve the confidentiality, integrity and authentication, what we are going to do? We are going to encrypt this particular message by the encryption algorithm. So we are going to get the confidentiality also. Coming to the digital signatures. So a digital code is generated and authenticated by a public key encryption, which is attached to an electronic transmitted document to verify its content in the sender's identity. It also guarantees about the non-repudiated services. The non-repudiation means someone cannot deny having sent the message once it have been signed with their digital signature. So the model of the digital signatures are, we have a signer as well as a verifier. So when the signer, what he does, he takes the data, applies the hash function, and we are going to get the hash code. Then we apply the signature algorithm with the signature's private key. Then we send the data using the data as well as the signature, and at the verifier we have the hash function, and we are going to check whether the hash from this particular signature and the data are equal or not. If both are equal, then we are going to say these has become verified this digital signature, and we are going to authenticate that particular person. Coming to the non-repudiation. So non-repudiation is the assurance that someone cannot deny something. So typically non-repudiation refers to the ability to ensure that the party to contract or a communication cannot deny the authenticity of their signature on the document or sending the message to the originator. So third usage is, so where we are going to see that we have taken the message, then we apply the hash function, then we are going to encrypt with the private key of A, and we are going to append with the plain text message, and this message is sent to the other end with the encryption as well as the plain text message. This plain text message applies the hash function and compares the hash code, and here decrypts the information by, since we have encrypted here with the private key, we are going to take the public key of A and decrypt and refer the hash code. If both are equal, then digital signature has been verified. Similarly, in this fashion also, we are going to get the authenticity. Here we are going to find the signature of authentication and digital signature. Here we are going to even find the confidentiality. So here digital signature, authentication and confidentiality. So what we are doing, the same process, but here we are encrypting with the encryption algorithm, and at the end we are going to decrypt. So here we are achieving the confidentiality, digital signature using this, and authentication using the hash algorithm. So this is one of the example, that is password verification. So using the hash function we can verify the password. So let us see, while storing the hashing password, so I am going to write the password and hashing that particular hash code, I am going to store them into the database. So whenever you are verifying, whenever you are logging into your mail IDs, you are going to give the password. So these passwords are again converted to the hash codes and verified into the databases. So the password that is lying in the database and the password that is being generated whenever you are giving or when you are going online, so those both are being compared. If both are same, then we are going to say as grant, or else we are not granting that particular access to the person. So like this the process works. So difference between the hash, MAC and the digital signature. So in the cryptographic primitive security goal, we have the hash, MAC and digital signature. So the integrity, authentication and non-repudiation is achieved by the digital signature. MAC access only integrity and authentication, and hash only the integrity. And in MAC we are going to use symmetric keys, and in digital we are going to use asymmetric keys. So there are certain popular hash algorithms, MD5, SHA, then RIPEMD, then Whirlpool and so on. So generally we use SHA functions mostly, which is one of the famous function. So hash function families are message digest and secure hash algorithms. So in SHA we have SHA-10, SHA-2, 256, 512, 384 bit, and the message digest family MD2, MD4, MD5 is being used. So RIPED was developed by the University Leuven team, and you have 128 bit, 160 bit, 256 bit and 320 bit. So coming to the hash function cryptographic and non-keyed digest. So non-keyed digest is used to provide the integrity function. The output fixed size hash value is called as message digest in cryptographic world, and we have the modification detection code. So we can take the message, we are generating the hash function, you are generating the digest, and it is being verified at the end. Keyed digest. In the keyed digest, we are going to take the authentication function. The output fixed size of the value is called as message authentication code, the secret key and the message. Then we are going to take the hash function with the symmetric key. We are going to achieve MAC. Then we are going to verify with the other end.